Calculus Unit 5, Day 39 notes. Our objective is to learn and apply the extreme value theorem to find absolute extrema of a function on a closed interval. Okay. In the last unit, we investigated on how to locate relative extrema of the graph of a function by using the derivative. So in pre-calc, we talked about the difference between relative and absolute extrema. So now we're going to distinguish the difference between the two. So what we have here, relative extrema are points on the graph of a function where the function must change from increasing to decreasing. And we'll look at this in a little bit, or vice versa, decreasing to increasing. Absolute extrema are just the highest and lowest points of the graph of a function. So I have some examples of relative extrema, and um, so increasing changes decreasing. We've dealt with that a lot. This is a cusp or a corner. It's increasing, then it's decreasing, increasing, then decreasing. Um, Same thing, decreasing, then increasing. So three examples of each, increasing to decreasing or decreasing to increasing. Those are relative extrema. And sometimes that's relative max, relative min. You've also probably used local max, local min. We talk about absolute mins and maxes. You probably may have heard the term global min and global max. Same thing as absolute. Okay, so we have two graphs here. I want to answer some of the questions. So um, on this graph of f of x, identify the coordinates of relative extrema of f. So, hey, this is negative 3, 0 is going to be a relative min. Why? Because it's decreasing, then it's increasing. 2, negative 6 is a relative min. Why? Because it's decreasing, then it's increasing. And then here, hey, this is a relative max. The question then asks down below, hey, what do we have for absolute max and absolute mins? Well, absolute, this goes on and on forever. Both tails go up, so you're not never going to have an absolute max, so there's none. But then I look here, just happens that this absolute min, excuse me, this relative min is also the absolute max. Okay, let's look at graph G. Okay, again, this is a relative min. Why? Because you're decreasing then increasing. This is a relative max. And here's another relative min. So negative 3, 4 and 3, 2 are relative mins. Why? Because it's decreasing then increasing. And negative 1, 4 is a relative max. Again, it's increasing then decreasing. So question might be, why can't these be relative mins and maxes? Well, this doesn't increase and decrease. It's not a tail that's going on and on forever, but let's look down for absolute min. Absolute min is going to be right here. This is the lowest point. So negative 3, 4 is going to be our, and that should have been negative 3, negative 4. Sorry about that. Negative 3, negative 4 is going to be our absolute min. And now, and there it is right there. And now the question is, what about our absolute max? Absolute max doesn't have to necessarily increase and decrease. It's just the largest point. And since this point's defined, where these tails go up, there's no absolute max. This is now going to be our absolute max. Okay? Even though this is a relative max, it's not the absolute max. This is the absolute max. And the absolute max does not have to increase, decrease, and the absolute min does not decrease, then increase. It can just be the largest value. So our absolute max is 6, 5. Okay? So on the domain of the given function, did the absolute extrema occur at the function's relative extrema? Well, the absolute extrema could occur, not always, but it could occur as it did in both f and g. So again, absolute min and absolute min just happened to occur where the relative mins were. However, this does not have to occur as the absolute max of g did not. It was its own point. Again, absolute min, absolute max do not have to increase and decrease or vice versa. All right, so let's continue with some of these examples on page 2 here. So graph of f of x on the interval from negative 2 to 3, what are the absolute extreme of f? So I'm just going to first look at the picture. I'm going to kind of break out. We're going from negative 2 to 3, and we're including the negative 2 and 3. So they want to know what the absolute extrema are. That's the very largest point and the very lowest point. And I can see here that the max between negative 2 and 3, this is the largest point. That's going to be negative 1, 3. And the absolute min is going to be this point right here, which is 2, negative 6. Okay, now let me just change pen color. We'll go to black. And the next one asks for the interval from negative 4, so that's right here, all the way to positive 1. Okay, and now once again they're asking for the absolute min, the absolute max. And remember, the absolute, it doesn't have to necessarily increase or decrease. So let me just, it's including the negative 4 and the 1. Let me just trace this with the black marker. Where am I going all the way to 1? Um, so I can see here, hey, this point right here is going to be my absolute max. Again, it's not restricted, but that it has to increase and decrease or vice versa. And this would be our absolute min. Okay, so they happen to be the endpoints. What you couldn't use, you can't call those relative maxes or mins. So this looks like negative 4, 4 and 1, 3 are going to be, 1, negative 3, excuse me, are going to be our absolute max and absolute min. Okay, next question. We'll answer that after we do graph of G of X. Okay, so from negative 4 to 5, including the negative 4 and 5, they want to know what the absolute extrema of G are. Let's do the absolute min. I look down here, and that's on the interval, and that's far and away the lowest point. So the absolute min is negative 3, negative 4. Now for the max, I kind of look, I go down, I will go way up here. Hey, that and the endpoint are at the same level. So in this case, we're going to have two absolute maxes. And this is going to be at negative 1, 4 and at 5, 4. So you can have 1, you can have 2, you can have multiple mins and maxes. Okay, let's go down and look at the next interval. And I'm going from negative 2 to 6, and I'm just going to trace this so I can just look at this one. Negative 2 to 6, and it looks like my endpoints are going to be both the min and max. So this right here would be a relative max. This would be a relative min. And again, relative min and max have to increase, decrease, or decrease and increase, but the endpoints don't increase and decrease, but that's not a restriction on the absolute min and max. So the absolute min is looks like negative 2, 0, and the absolute max is 6, 5. Okay, so down bottom, when the domain is restricted to a particular closed interval, at what three places that the absolute extrema could exist? I really should say places could the absolute extrema exist. And those absolute extrema can exist at the endpoints where the derivative is 0 and where the derivative is undefined. And this is going to lead to, on the bottom of page 2, the extreme value theorem. Extreme value theorem. If a function is continuous on a closed interval from A to B, which that means the A to B have to exist. So wherever I am, here's point A, go whatever, and this point B. So, because those could be, or maybe they're not, but they could be an absolute min or max, then the function is going to have at least one absolute max and at least one absolute min. So in my new drawing here, let me just readjust that. One endpoint can be, this would be my absolute min, because again, it doesn't need to be worried about increasing, decreasing. This right here is where the derivative is 0. That would be my absolute max. So as long as it's a closed interval. If it was open, then the extreme value theorem does not hold. All right, let's go on to the next part of day 39 note.